Welcome back to another Sunny Day Mathematics. Woo, woo. Warm up 102 should come up on your screen. Let's get started, please. We have a minimum day, so it's going to go pretty fast, so stay focused. Thank you. All right, let's get the show on the road. Let's see, get us started with what you get for mu. How about mu? What's the name that has an M in it? Mu. About Amelia. What you get for mu? 22.8. Looks about right. Next, share with your neighbor the variance. By now you should know what variance is. Then Amelia is going to pass someone. Go ahead, Amelia. Who? Logan. Variance. Oh, 275 point something or 0.14. Hands have got anywhere from there to 300. Yep, okay, not bad. Standard deviation. Pass someone, Logan. 16.59. All right, pretty close. All right, so let me go with 16.59, so that would be 39.39. Is that correct? Okay, thank you. And then on the downside, we got 6.21. All right. We need a z-score for the number 1 in the data set. Share with your neighbor what you got for the z-score, and then Cole's going to pass him one. All right, good communication. Cole, pass him one. Who? Oh, Alessandra? She just got here. How about, let's pass it to Brandon Darty. What'd you get, Brandon? Negative 1.2. Seems about right. So negative 1 is here at the negative 1 standard deviation. 0.2 a little bit further to the left. Here's my z-score for the number 1. What does that mean? Tell your neighbor, what does that mean? If the number 1 on the data set scored about right there, what does that mean? Brandon, pass him one. What does that mean? Out of the norm, that is correct. It's not in the norm, norm's right there. Okay. Are we done with measures of variation? Which one are we missing? Everyone, what is the range? 53, that is correct. All right. Also, problem number 2 reads, it is your 10-year IHS reunion. So, think further to 2035. By then, I think we're going to be flying already in cars or something. What have you accomplished in 10 years? In other words, what will you share with your classmates? 10 years. It's a long time. Something to think about. Trying to make sure you keep those in mind. So make sure you share. Send that in as soon as you can. All right? Yes. Let's go. All right, copy the agenda, please. Warm up 102 done. Discrete probability distribution. And tonight, hopefully study your formulas, because it's been a while since we had a long formula pop parte hot max. Because we had 30-some formulas for statistics only. Then we added about 10 to 14 of probability rules and such, right? Yes, Mr. Q, we love those. All right, good. With addition, multiplication, conditional, permutation, combinations, basic probability rules, and such. All right. Next, your home plate. That was last night, so make sure you turn that in on Canvas right now. And also turn in your sign progress or screenshots. Do that right now and then get a Cornell note ready for today's session. I'll give you some time. All right. Thank you for submitting your home play and your sign progress. So, our objective for today, I can define and compute discrete probability distribution. So we did the intro, a simple intro for a discrete probability distribution. And one question that comes to mind for me is that, do you understand what probability distribution is? What does that mean when they ask you for you to produce a probability distribution? Talk to your neighbor, let them know what does it mean to produce a probability distribution. See if they know. What does that mean? All right, what does it mean to produce a probability distribution? Let's go with Mel. What does that mean? Brandon Darty. Pass it back to Mel. Santi. A table, that is correct. Make a note for yourself, please. Whenever you see that they ask for a probability distribution, they mean that they need a table. But not any type of table. The table where the probability of X has to add up to what magic number, people? Yes, 1. The probability has to add up to 1. Once again, they ask you to produce a probability distribution. That means a table, but the probability has to add up to 1. All right. So, really quick, we know what classical, empirical, and subjective probability is. We talked about variables being discrete and continuous. Discrete being that you are able to count them. Continuous means that you cannot count them because it's not a steady number. Look at this one. Once again, what is this called, everyone? It's called a what? Probability distribution. And all these numbers that go here need to add up to how much? 1. That is correct. So, you did a couple in class. You did that one, this one, and this one. So, with that said, problem number 3, look at it. Don't copy it. And it reads, is the following a probability distribution? Elaborate why or why not. Talk to your neighbor. Is that a probability distribution? Why or why not? And then type it up on your screen, please. There it is. No, it's not a probability distribution because it doesn't add up to 1. It adds up to 11/13. All right, not bad. Go to the next one. And it reads, is the following discrete or continuous? Tell your neighbor which one is it and why. The speed of a jet airplane. Talk to your neighbor and then type it up on the screen, please. All right, looks like the majority of us say continuous. That is correct. Move on to the next one. Next one. Is the following discrete or continuous? The number of books in the IHS library. Tell your neighbor what it is and why. All right, looks like the majority says discrete. That is correct because there's only a finite number of books at the library. Let's go to the next one. The number of people who play lotto. Be careful with this one because there was a little debate earlier in regards to this one. Think about it. Think about it through. No? All right. So question. Would we ever be able to count how many people play lotto? No, right? Therefore, this is continuous. Unless it was phrased, is the number of people who played the lotto this past Friday, then there is a explicit amount of people. That make sense? All right. Go to the last one. It says construct a probability distribution and graph. I don't want the graph. I just want you to build a probability distribution for that. And then turn it in on the screen, please. Go. Shouldn't take you long. That looks about right. Items at the top, P of X at the bottom. Now, question, is that a probability distribution? Talking to your neighbor, is that a probability distribution? All right. All right, let's see. Austin, T, is that a probability distribution? Yes, why? The probability equals 1, that is correct. All right? Pretty good, pretty good. So, good review. I'm going to stop right there. Now, once again, we have a lot of formulas. Make sure you're keeping up with your studying, please. Those of you following on YouTube, once again, study your formulas. Talk to you guys next time. Peace.